Pertains to Emily, a triathlete with a PAL score of 2.2. So how active is that? That is female PAL score 2.2, extremely active. We also know that she weighs 129 pounds, and we also know that her body fat percentage is 26.7. So if we input this here, we're only given her weight, 129 pounds. Type that in right there. And our body fat percentage, let's get down to that. Our body fat percentage of 0.267. And then we can compute our fat-free mass. And again, our fat-free mass is simply the mass of the body minus the fat. From that information, it's our lean body mass, we can compute the Catch-McArdle formula, and we arrive at the conclusion that her BMR is about 1,300 calories per day. If we type in an activity factor of 2.2, which was provided to us, then we can simply multiply her BMR times her activity factor of 2.2. So if we were to do that, again, this is how we arrive at this number here, is I take that number times 2.2. Whoops. I used the other one. It didn't look right. So equals that number, Catch-McArdle, times 2.2. And that's how we get our 2856, which is right there as our option. Now, how you also can compute this is to create a drop-down. You ask, well, what equation am I using? The Catch-McArdle equation, which uses lean body mass and body fat percentage to get that, or the Harris-Benedict equation, which of course uses the age, the gender, the weight, and the height, and not the body fat percentage. So if I'm only given age, gender, weight, and height, then I have to use Harris-Benedict equation. But if I'm only given weight and body fat percentage, then I have to use Catch-McArdle. So in this case, I was given weight and body fat percentage. Let's use Catch-McArdle. And this says, well, if I chose Catch-McArdle, then I'm drawing from the F column, and if I didn't, then I'm drawing from the G column, which is Harris-Benedict. Here, this is just a activity factor that's drawn from over here, and we're using this in order to compute this number. Alright. Then we have another question about Emily. We want to know how many grams of carbohydrates should she consume on a daily basis in order to maintain her body weight, which is assumed, based on her activity level, which is pretty high. Now, this, of course, is in the nutrition page. So what do we have to do here? Well, we have to carry over some information. We know that her PAL score is 2.2, so that stays. And then we can carry over her total daily energy expenditure from, say, right here. That's our answer. And then what this is going to do is filter through, actually it's going to go through really the 2 here, because it doesn't even go up to 2.2, but we're just going to keep the same values. It says that carbohydrates, we have a lookup function that's going to go and look up 2.2. Closest to it is 2, and so it's going to say 65% carbohydrates. So 65% of her total daily energy expenditure is going to be devoted to carbohydrates for the nutrition recommendations. How many calories is that? Well, that ends up being 1,856 calories, which we can get by computing total daily energy expenditure by 0.65. What's 65% of 2856? It's 1856. So then we can, I think we're asked about grams, right? Yes, we were asked about grams, so then we have to do one more step and convert calories to grams, and of course carbohydrates. We know that we have 4 calories for every gram. So in order to go from calories to grams, you have to divide by 4. And that's exactly how we get 464.2 grams. Okay, closest here is 46.1. At some point there was a rounding error, But regardless, that's our answer.